Good afternoon, class. We are looking at Chapter 4, Application of Derivatives, Section 4.1, Maximum and Minimum Values. So in this chapter, we're going to look at maximum and minimum values, how derivatives affect the shape of a graph, optimization problems, antiderivatives, also known as integrals. This is extremely important that we know all these differentiation formulas so we can go with the reverse process known as antiderivative, anti-differentiation, integration, you name it. So you see various formulas here. We also have the definition of a delta y, dy, delta x dx, and linearization, which refers to finding tangent lines. So we start with the definition. Critical point, for short CP, a critical number point of a function f is a number c such that f prime is 0 or f prime dne does not exist. So for example, if we have f of x equals x cubed plus 3x squared minus 24x, and we want to find the critical points, let's go with all these steps. Number one, find f prime of x. 3x squared plus 6x minus 24. So that's the first step. Second step, we want to set this equal to 0 and solve. F prime of x equals 0. First, let's factor out number 3, and we get 3 times x squared plus 2x minus 8. Furthermore, we can factor this. We want two numbers. The product is a c or negative 8. The sum is b or 2, and those are positive 4 and negative 2. When we set this one equal to 0, it gives us negative 4. When we set this one equal to 0, it gives us positive 2. If they ask for a pair, you have to put the negative 4 in here and find the pair negative 4 comma, and you have to put 2, find the pair 2 comma. The third step says f prime dne does not exist. And when you look at f prime, it's a polynomial of degree 2 or a quadratic function which exists everywhere. Let's look at some definitions, formal definitions for extrema. Absolute or global extreme, where extrema refers to both max as well as min, okay, either maximum or minimum, we call them extrema, which is the plural of the word extremum. So absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values in the domain. So for all x values in the entire domain. So if we look at this graph, we have peaks and valleys. This is a valley, this is a peak, this is a valley, and this, there is no other point having a smaller y coordinate, therefore it's an absolute minimum. This is the location of that. Absolute max occurs at the point C if f of c is larger than or equal to f of x for all x values in the entire domain. And this is a peak, valley and peak, and there is no other point having a larger y coordinate, therefore it's an absolute max. Local, also known as relative extreme values. A local minimum is the minimum value within some open interval. Local minimum occurs at the point C in an open interval of a to b. Remember, we use parentheses to represent an open interval. In the domain, if f of c is less than or equal to f of x for all x values in this open interval. So in this case, we have a local mean, and finally a local max is the maximum value within some open interval. Local maximum occurs at the point C in an open interval of a to b in the domain if f of c is larger than or equal to f of x for all x values in this open interval. would be this. Now, I want to explain something to everybody, and that is, if you go back to this graph, this is a local mean, this is a local max. This point is also a local mean. It happened to be an absolute max because there is no other point having a smaller y coordinate in the entire domain, but it is both local as well as absolute. Local max, local mean, local max, and this happened to be an absolute max also because there is no other point having a larger y coordinate. Local mean, local max. The reason this is local because there are other points having a smaller y coordinate. The reason this one is local because there are other points having a larger y coordinate. Local mean, local max. Local or relative extreme values using Fermat's theorem. If a function f has a local max or a local mean value at an interior point C of its domain, and if f prime exists at C, then f prime of C must be 0. We have a local max here, we have a local mean here. Notice if we draw a tangent line, is a horizontal tangent line, and as you know, the slope for any horizontal line is 0. M is 0, and that's the concept. This one is a local max as well as an absolute max because in the entire domain, no other point has a larger y coordinate. So this point, but at this point, I hope you realize it's a sharp corner. And f prime does not exist. Now, local extremes in the interior of the function occur where f prime is 0 or f prime is undefined. That's what happened here, undefined or doesn't exist. Maxima and minima of a function always occur at critical points. You can see it here. But critical points are not always maximum or minimum values. So if we have maximum or minimum, there has to be a critical point there. But if you have a critical point, it may or may not be where the extreme are. Let's look at a very simple example. This is a quadratic function or a polynomial of degree 2 with the domain being all real numbers. This is the location of a local mean as well as absolute mean. We don't have a local max or local mean. If we want to be more specific, this is equal to 0 at the pair 0, 0, and it is the y coordinate that gives us the absolute mean here. We're going to change it to a closed interval of 0 to 2. So this is the location of an absolute mean. This is the location of an absolute max. We don't have local extrema. I want to mention a couple of things. Endpoints can only be absolute extrema. They cannot be local. And for example, if we look at this point, has coordinates 2, 4. So this is 4 at this point. Sometimes they say it's equal to 4 at x equals 2. And you want to always pay attention to the digital homework that you do and the way they want you to answer. Let's make a slight change. Half open, half closed. So this point is not included, so we don't have a minimum, local or absolute. But we still have an absolute max, again, no local max, same as before. And let's make it completely open on both sides. So the endpoints are not included. We don't have a max, we don't have a mean, because the endpoints are not included. Extreme value or closed interval theorem. If f is a continuous function over a closed interval of a to b, then f has a maximum and minimum value over that interval. So the keys are number one, continuity, number two, closeness. So it has to be a continuous function and we have to have a closed interval. So take a look at this case. Absolute max here, absolute mean here, maximum and minimum at interior points. Absolute max here, absolute mean here, max and minimum at end points, max here, mean here, maximum at interior point, minimum at end point. So what is the process of finding absolute max and mean when we have a closed interval theorem? First, find the critical points, CPs, and evaluate the function at those points. Then find the values of the function at the end points f of a and f of b. Remember, this is the closed interval of a to b. So those are considered the end points. So f of a, f of b. The largest value is the absolute max, and the smallest value is the absolute mean after we go through the process. So as an example, we want to find the absolute max and mean for this function f of x equals 1/3 x cubed minus 9x in the interval of -6, 0, which is a closed interval. And here's the methodology. But before we look at the methodology, number one, we have to see the continuity. If we look at this function, this is a polynomial of degree 3 or a cube function. Every polynomial is a continuous function in the entire domain of negative to positive infinity, every polynomial. Therefore, this function is also continuous from -6 to 0. So first we have to pay attention to the function and see what happens. So polynomial of degree 3, continuous from negative to positive infinity, therefore continuous from -6 to 0. Now let's go with the methodology, which says find f prime of x. 1/3 times 3x squared makes it x squared minus 9. Then it says, look where f prime is 0 or doesn't exist. So first and foremost, we set it equal to 0, which means we need to factor it. X plus 3x minus 3. So when we set it equal to 0, this gives us -3, this gives us +3. Also, we have to look at f prime doesn't exist. This doesn't produce any answer. I want to explain what that means. This f prime of x is a polynomial of degree 2 or a quadratic function. Again, domain is all real numbers. Therefore, it exists everywhere and it doesn't produce anything. This is phi, the letter phi, which represents an empty set in set theory. So there are two answers. Take a look at the given domain. Is -3 in between -6 and 0? Yes. Is 3 in between? No. So we can only use -3 as a critical point of interest. And I went over this concept. I'm going to remind you, this means, this looks like an epsilon. This means an element of. Now, the next step is to evaluate this function at -6, at -3, at 0. So the endpoints, obviously 0 gives you 0. So if you evaluate them, for example, f of -6 means 1/3 -6 cubed minus 9 times -6 minus 72 plus 54 as an example, and it gives you -18. F of -3 means 1/3 -3 cubed minus 9 times 3, and you see that it's times -3. So it makes it -9 plus 27, which is 18. So clearly, this is the largest number. So absolute max is equal to 18 at this pair. Smallest number, absolute mean equals -18 at this pair. So this is the way I would like to write. This is the third step. Absolute max is 18 at this pair. Absolute mean is -18 at -6 comma -18. So that's pretty straightforward. Here's the function f of x plus 3 to the power of 2/3 minus 5 in the closed interval of -4 to 5. First and foremost, what type of function do we have and what is the domain? I want you to notice that this is the cube root of x plus 3 to the power of 2 minus 5, which makes it a cube root, essentially being raised to the power of 2, and then moving down by 5. Any cube root, the domain is all real numbers. Therefore, if the domain is all real numbers, which means continuous from negative to positive infinity, it is also continuous from -4 to 5. So the next step is to find f prime of x. So 2/3, it's easier to use this one. 2/3 times x plus 3 to the power of 2/3 minus 1, which makes it -1/3, times the derivative of the inside, which is 1. And we are going to take this down to make it positive 1/3. Now, f prime is 0, f prime doesn't exist. That's what we are going to work on. If you set this one equal to 0, a fraction is 0 when the top is 0. And whenever the top or the numerator is a number, you can't make it 0. Therefore, there is no solutions. So when f prime is 0, that means the numerator, any fraction, the numerator is 0. Numerator is a number, therefore there is no solution. F prime doesn't exist. A fraction does not exist when its denominator is 0. Doesn't exist, or it's undefined. So you set the denominator equal to 0, and you can clearly see that x must be -3 to add up to 0 with this. So x equals -3. Is this in between the given domain of -4 and 5? Yes. Therefore, we can use that. So -3 is between these two. Now we are going to evaluate this function at -4, at 5, at -3. And by the way, I hope you see if you plug in -3, this goes to 0, the answer is -5. That's the easiest one. What about the others? If I plug in -4 I get -4. If I plug in -3, I get -5. If I plug in 5, I get -1. I'm going to quickly show you. So if we plug in -4 here, so -4 plus 3 quantity squared minus 5. So -4 and 3 is -1. Cube root of that is also -1. Squared minus 5. 1 minus 5, and it gives you -4. So I hope you see that. So what about 5? Let's work on 5. If I plug in 5, I get cube root of 5 plus 3, 8. And I'm going to square it. Minus 5. Cube root of 8 is 2. 2 squared is 4. 4 minus 5 is -1. So I hope you see it's very easy to calculate it even without the calculator pretty fast. The largest number is -1. So the absolute max is -1 at this pair. The smallest is -5. So the absolute mean is -5 at this pair. And we do the writing as follows. Let's move on. We want to find the absolute max and mean for this function in the interval of 0 and 4. Let's first find the domain. This is a rational function. What is the domain of any rational function? You find the denominator and you exclude that. As you can see, the denominator can never be 0. Why is that? Because you have x squared plus 2. So if you set the denominator equal to 0, that gives you no solutions. Therefore, this rational function is continuous from negative to positive infinity. It makes it also continuous from 0 to 4. So although it's a rational function, the denominator, when you set it equal to 0, doesn't give you any solution. So the domain is all real numbers. Therefore, it is also continuous from 0 to 4. Let's find the derivative using the quotient rule. If we call this f, if we call this g, we are going to use f prime g minus g prime f over g squared. The top gives you 1 times the bottom. 1 times the bottom minus, but the bottom gives you 2x times the top, which is x. And just write the bottom and square that. So we have f prime g minus g prime f, and this is g squared. So we have x squared plus 2 minus 2x squared, and these two add up to negative x squared. So we found f prime. What do we do next? We look at two things. F prime is 0, f prime doesn't exist. F prime is in the fractional format, or a rational expression is 0 when the top is 0. Minus x squared plus 2 is 0. That means x squared is 2. And x is plus minus square root of 2. F prime does not exist. The denominator is 0. And as you can see, and it was discussed, the denominator can't be 0. This is being raised to the power of 2. It's the same denominator being raised to the power of 2. Therefore, f prime doesn't exist, doesn't produce any answer. There is no way to make this undefined. So let's look at both answers. Is square root of 2 in between? Remember, square root of 2 is about 1.41. Yes. Is minus square root of 2. Even if you don't know what it is, a negative number is not between 0 and 4. So the only acceptable answer from here, we have two of them, only square root of 2 works. So we are going to evaluate this function. If you plug in 0, I hope you realize you get 0 over any number is 0. 0 over, of course, a number other than 0. So if you plug in 0, you get 0 over 2. If you plug in 4, we get 4. Over here is 16 and 2, 18, 4 over 18, which becomes 2 over 9. If you plug in square root of 2, you get square root of 2 here. This one square root of 2 gets square root of 2, and 2 is 4. So that's how you arrive at the answer. So again, if I were to write that, would be, this one would be square root of 2 over square root of 2 squared plus 2. This would be 4 over 4 squared plus 2, which makes it 4 over 18, which simplifies to 2 over 9. Now, if you don't recognize which is the larger of the two, you can go to a decimal representation, but for the sake of argument, this is 1.41. And so clearly it's larger than this. So the absolute max is this. At this pair, the absolute mean is this at this pair. It's very straightforward, class. All right, we can move on to the next question. Find the absolute max and mean for the following function. F of x is x to the power of 4 minus 18x squared in the interval of -4 to 1. Well, first and foremost, this is a polynomial of degree 4, which makes it continuous from negative to positive infinity. The domain is all real numbers. Therefore, it also makes it continuous from -4 to 1. That's the first thing. So we have a polynomial of degree 4. The next thing is to find the derivative, which is 4x cubed minus 36x. To set this equal to 0 or look at whether it doesn't exist, we have to factor this. So I'm going to factor the 4x out because 36 and 4, both of them are divisible by 4. So 4x comes out and it gives us x squared minus 9. And as you know, x squared minus 9 is x plus 3, x minus 3. And now if we set this equal to 0, it gives us x equals 0, x equals -3, x equals +3. And this multiplier, doesn't matter, it's 4, 4,000 or -10, makes no difference as far as the results are concerned. So there are three answers, 0, -3, and 3. And f prime doesn't exist. F doesn't give us any solution. The reason being because f prime itself is a polynomial of degree 3. So it works everywhere. It works everywhere. All right. So what it means is, let's see which ones are in between. Look at the given interval. 0 is in between. Yes, we're going to use the 0. -3 is in between. Yes, I'm going to use -3. Is 3 in between? No, we can't use that. So we can only use these two. So we're going to write 0 and -3 would be an element of this domain. So we are going to use those and we're going to use those. In other words, we have two critical points to use and we have the endpoints. So you just have to plug in. So what happens when we plug in? So I write, you have to really evaluate this. For example, for -4, let me show you. For -4, we're going to write -4 to the power of 4 minus 18 times -4 to the power of 2, and we can simplify to -32. For -3, we have -3 to the power of 4 minus 18 times -3 squared. 0 clearly makes it 0, and 1, of course, 1 to the power of 4 minus 18 times 1 squared clearly makes it 1 minus 18 or -17. So the largest value is 0 because everything is negative. So that's the absolute max at this pair. The smallest value is -81. So the absolute mean is that at this pair, and we're going to do the right. Absolute max is 0 at 0, 0. Absolute mean is -1 at -3, comma, -81. So we are looking at extreme value or closed interval theorem. We want to find the absolute max and mean values of f on the given interval of -1 to 2. So we need to know what is the domain to begin with. So this is, if we were to rewrite it, I want to make sure we understand what we have here. F of t is a t square root of 4 minus t squared. So what is this? This is the product of a linear function t and a square root function 4 minus t squared. And as you know, a linear function doesn't have any restriction. It's a polynomial of degree 1, and the domain is all real numbers, but this one has a restriction, and the restriction is the radicand must be non-negative. That is how you find the domain, which is 2 minus t times 2 plus t larger than or equal to 0. If you set this one equal to 0, you get t equals 2. If you set this one equal to 0, you get -2. And you need a sign graph. I'm reminding you of what we have seen in elementary algebra. Sign graph. So it ends up with, let's say, -2 here, 2 here. At -2 becomes 0, at 2 becomes 0. So if you pick a TP short for test point, And the easiest one would be really the one in between. So in between, the easiest one would be 0. If you pick 0 and you plug it into this one, you get +2. In this one, +2. Their product is +4. We just want the sign. On the left side, you don't really have to pick up a test point. They alternate because each one is of degree 1. So this is of degree 1, this is of degree 1. Whenever it's degree odd, it alternates. But if you want to pick up a test point here, you can pick -3 and put it in here. And notice if you put -3, the first one is positive, the second one is negative, their product is negative. And over here, we can put 3, and that when you plug in 3, the first one is negative, the second one is positive, the product is negative. And what we are interested in is here, which gives us the domain of -2, 2, and we write down the limiting factor is this square root, so we can call it a square root function as a result. It's really the product of a linear function and a square root function. And the domain is from -2 to 2, and it's continuous from -2 to 2. Therefore, it's continuous in the given interval. This part is algebra. We are showing that, yeah, we can work with that. So the next step is to find f prime of x. So to find f prime of x, we're going to work with this. This is f, this is g, so we are looking at f prime g plus g prime f, the product rule. T gives you 1 times 4 minus t squared to the power of 1/2 plus g is this part. So how do we differentiate this? 1/2, the same thing, 4 minus t squared to the power of 1/2 minus 1 or -1/2 times the derivative of the parentheses by the chain rule, which is -2t, and then times f. So this one, and then times t. If I were to write this, I would write it as follows. This is f prime g. This is g prime f. That's how you define it. So very straightforward. So let's write each piece. And this one is 4 minus t squared to the power of 1/2. That means the square root. Now this one, okay, is the same as this one, square root, but underneath. And then 1/2 cancels out -2 and makes it minus t. So I hope you realize the second part. I want to discuss the second part. This whole thing has minus t times t at top, and then this with the positive 1/2 at the bottom. Therefore, this one will change to a square root like this. This one is plus changes to minus because minus t times t is minus t squared. And then this goes down, becomes positive 1/2 or a square root. This is all algebra. Class, this is the only calculus step. Calculus step done. How do we put this together? Let's take a common denominator of square root of 4 minus t squared. And I'm going to write this one minus t squared. In other words, the second one doesn't change. But what happens to this piece? This piece gets multiplied by this piece. I hope you see that, because you want to raise it by a factor of square root of 4 minus t squared. When you multiply, it just comes out as 4 minus t squared. And we can combine these two into minus 2t squared. So that's how we combine. Now, so all we did so far was to find f prime. So where is f prime 0 when the numerator is 0? F prime is 0, the numerator is 0. That means 2t squared is 4. That means 2t squared is 4, t squared is 2, and t is plus minus square root of 2. That's the meaning of it. Again, let me clean up the mess. F prime doesn't exist. A fraction doesn't exist or is undefined if the denominator is 0. Now, square root is 0 if what's underneath is 0. So 4 minus t squared is 0. So if this is 0, 4 minus t squared is 0. 4 is t squared, and t is plus minus 2. All right. What happens next? We have to figure out what's in between -1 and 2. Is square root of 2 in between? Yes, because square root of 2 is about 1.41. Is minus square root of 2 in between? No. Minus square root of 2 is minus 1.41. No. So square root of 2 works. 2, well, it's one of the endpoints. -2 is out. So in essence, you just have square root of 2 in essence. 2 works also, but 2 is already one of the points we need to use. Let me also clean up this mess. And so we are going to evaluate the original function at -1, +2, and square root of 2. So just as an example, at -1, let me work it out first. I want to evaluate this, which is, let me just write it here. F of t is t square root of 4 minus t squared. It's easier to use that one. So if I want f of -1 means -1 square root of 4 minus -1 squared, which makes it -1 square root of 4 minus 1, which is 3. So this is minus square root of 3, as an example. If I want square root of 2, so this is square root of 2, square root of 4 minus square root of 2 squared. So this is square root of 2, and this is 4 minus 2, which makes it square root of 2 times square root of 2, which makes it 2. So we calculated 2 of it. The last one is number 2. If you plug in 2 here, I hope you realize it becomes 4. 4 minus 4 is 0. So it's 2 times 0 to the power of 1/2. 2 makes the statement 0. Therefore, we have the following. F of a, meaning the first endpoint, -1, we showed it's negative square root of 3. F of the critical point square root of 2, we worked it out and we showed it's 2. F of 2, if you plug in 2, this is 2 and this becomes 0, the product is 0. Therefore, the largest value is 2. So absolute max is 2 at this pair. The smallest value is the negative number. That's the only negative number. So the absolute minimum is negative square root of 3 at this pair. It's very straightforward, everybody. So absolute max is 2 at square root of 2 comma 2. Absolute mean is minus square root of 3 at negative 1 comma negative square root of 3.